Hi, this is Dan Breeker at the University of Texas, and this video is about the paleosol data tab for the paleosol template for the CO2PIP project. There's more general information in another video that I made about all of the various tabs in this workbook, so you can check that one out too if you have questions. The most important thing, I guess, or at least where I want to start, is in the upper left here, and just call your attention to this cell where it says that on this sheet, each row corresponds to an individual carbonate nodule or other carbonate type, an individual tooth or bulk paleosol sample, and not every row will necessarily have a CO2 estimate associated with it. So I'm going to come back to that as we move through this sheet, but remember that each row is going to correspond to an individual nodule, and that will influence how you're filling out this sheet. The initial columns here that we're looking at right now are mostly going to be pre-populated. You can look at the other video for information about that. And there are a lot of columns on this spreadsheet. I'm not going to go through each one of them, but rather what I'm going to do is go over some of the columns that I think maybe need just a little bit of extra explanation. And before we do that, I also want to just remind you all that at least initially here, we're going to be filling out these sheets for the archive. And what I mean by the archive is that we want the sheets to represent as closely as possible the original publication where the data were reported. And that means that methods may have been updated, ages may have been revised, so on and so forth. But in the archive, we want to represent the original publication as closely as possible. And that gets a little bit confusing because sometimes there's data that you're entering where you know that's actually not how we understand it anymore, or you know that's not correct, but that's what we're entering in here because we want this to be, again, as closely represent the original publication as possible. Okay, so that's for the archive. Once we are finished with the archive, we will move on to the product stage. And for the product files, that is when we make corrections, updates, so on and so forth. So there's going to be two stages here. And I want to say that at the outset here because there are some ambiguities associated with, okay, am I filling out an archive sheet or am I filling out a product sheet? And we're going to start with the archives. Okay, so I'm going to move to the right here through these columns. And the one I want to stop at first is called the section number. We've included a column for section number here because we recognize that some publications, some CO2 records use more than one section, maybe like composite sections. Some people think about it that way to make a CO2 record. And this column allows the user to disambiguate one section from another. And it's going to become particularly important when we start comparing data that are entered on this tab, which is for the paleosol data, with data that are entered on the age data tab here. That also has a column for stratigraphic level. Here's the stratigraphic level column on this sheet. The age data tab also has a tab for stratigraphic level. And we want to be able to compare those with each other. And if there's multiple sections involved, column X allows us to handle that. Okay, and then we're also asking for the ages here. And there are various ways that ages can be determined in sedimentary rocks where we find these paleosols. And so most of that is being handled on the age data tab. Again, I'll make another video that will go over the age data tab. But here we just want kind of the summary of the information that's on the age data tab. So we want to know the age at each stratigraphic level where there are paleosols that were used to reconstruct atmospheric CO2. And then these two columns after age are available to report the uncertainty. So there's multiple different options here. For instance, if you knew the age just to the stage, you could put the midpoint of the age of the stage and then the length of the error bars extending to the beginning and the end of that stage. And then for the type of uncertainty, you could say, well, that's a uniform distribution. There's equal probability of any age within that given stage. But right, there's other things you could do too. You could report them as standard errors or percentile values. We tried to make this as flexible as possible to accommodate all the different types of geological constraints or geochronological constraints. Okay, I'm going to move over to column F, column AF now. And this column is titled paleosol number. And there are a number of reasons why this might be useful, and we decided to incorporate it as a column. One reason is that some people like to reconstruct CO2 from a number of different samples, from a number of different depths below the paleosol surface, all within one paleosol, and all that information gets combined together to make a CO2 estimate. And usually, the way these records work is that there's a number of CO2 estimates all from one section, and we want to be able to link together samples and data that are all part of one paleosol and distinguish those from samples or data that are all part of a different paleosol. So even if these were not originally numbered as part of a study, right, we want them to be numbered here so they can be disambiguated from one another. Another way this is useful is that sometimes the materials that are used to reconstruct atmospheric CO2 are not from the same exact stratigraphic level. They may be close by, but not from the same exact stratigraphic level. So this allows us to link, let's say, for instance, the paleosol carbonates that were used are from one stratigraphic level, and the organic matter that was used is from just slightly higher in the section, maybe 30 centimeters higher or something like that, right? If you want to link those two together and say those two organic matter and delta C13 values of the carbonates, that if those were used to reconstruct atmospheric CO2, we want to give them the same number in this column so that the user knows that they were combined together or compared together to make an atmospheric CO2 estimate. Okay, and then I'm going to move over to column AG, where there are delta C13 values of paleosol carbonates that can be entered here. And remember, on this sheet, each row is going to be one nodule or whatever type of carbonate is being analyzed. And so I might say, okay, well, one nodule had a delta C13 value of negative 5.6 per mil. Another nodule, even if it's from the same stratigraphic level, I need to enter it onto a different row because the replicates are by nodule here. So with another nodule, even if at the same stratigraphic level, maybe it was negative 5.9, and maybe there's a third even, and it's negative 4.8, and so on and so forth, right? Then the next column over allows you to report the error on those estimates. And so for some people, there are multiple analyses made on each nodule. So if this nodule, the negative 5.6, if that's the mean of a number of different analyses from one nodule, then I could say, well, maybe the standard deviation is 0.3 per mil, and maybe I made 3 analyses on that individual nodule. If that's not the case, if you only made one measurement per nodule, then this can remain NA, and this can be 1. Right, so that's the way it's going to work. Each row is for an individual nodule. And then all of these columns in blue are sort of similar in that sense, so I'm not going to go through all of them, but I want you to just be thinking about the fact that it's one row per nodule. Now, if you have, for instance, bulk delta C13 or delta C13 values of bulk organic matter, right, and they're from this nodule, right, certainly that can go on the same row as that nodule. So, right, this might be negative 23 per mil. And even if you had other values here that were from the same stratigraphic level, they could also go on the same row. Like for instance, if there was a tooth that was at the same level as a nodule, you could put that on the same row as that nodule, and that's going to be fine. What we really, the way this is set up is we really just want each individual nodule on a different row so that we can look at the distribution of values. Okay. And then I'm going to keep moving over here. I just want to, there's one exception to this rule of one nodule per row, and that's with the clumped isotope analyses. And for clumped isotope analyses, the replicate is measurements of different aliquots of the same powder. And so when we're entering clumped isotope temperatures here, we want to look at, okay, it could be one nodule, and there might be a number of replicates of one spot even on one nodule, and that's how things are being reproduced. So it's not per nodule for the clumped isotopes, but rather it is per sample of powder, because that same powder is analyzed many different times to get a clumped isotope temperature. So that sort of violates our rule of one row per nodule, but that's the only way it'll be violated is for the clumped isotope data. Okay, and if we keep scrolling over, just want to show you that there are a number of places to enter atmospheric CO2 estimates, right? Atmospheric CO2 estimates might be reported as a mean. They might be reported as a median. There is space to put in the uncertainty associated with those CO2 estimates. There's place to put in the percentile values, right? So lots of different ways to think about the averages and the errors that are associated with the CO2 estimates. Especially for the archive files, many of these columns may be NA, not applicable, because they just weren't reported. And the last thing I want to say for this sheet is that I think NA in and of itself can be a little bit confusing. I mean, NA really means not applicable. And so certainly there are some of these columns that are not applicable for the particular approach that's being taken for that CO2 record. And those are going to stay NA. But there might also be, especially as we enter data for some older studies, there might also be some columns that really should be filled out given our modern understanding of how this proxy works, but that those data weren't reported. Those are sort of like incomplete data sets. And still, right, even though, right, those columns, we might think they're applicable, right? We should have them. We would like to have those data. It's not that they're not applicable, but we're still going to use not applicable if those data are not available. So I guess we could think about that as not available, but it's still going to be NA. And we've gone ahead and pre-populated all of these cells with NA to just kind of make it easier. One thing that we've heard from people is that, wow, I don't feel right. I don't feel like I'm doing the spreadsheets right because there are so many columns that are just full of NAs. Don't worry, that's probably okay. Most of these spreadsheets are going to have mostly NAs. And the reason for that is because there's so many different ways that people reconstruct CO2 from paleosols. We want this to be comprehensive. And so not all of these columns are going to apply to every study. Please check out the other video on the age data tab, and also the video on the all of the tabs, a kind of a general overview of this spreadsheet for more information. Okay, thanks very much.